Alright, so we have graphed, we talked about characteristics, we talked about transformations, but we have to be able to apply it. We have to be able to apply these things, these skills, this quadratics, in a word problem. Alright, so we can either have projected objects or we can have falling objects. So this formula is used when an object is being projected. Okay. We could also look for keywords like thrown, tossed, or catapulted. So projected objects are going to use this formula here. Okay. H of t is a height at time t, which means t stands for time. VO stands for velocity. Okay, and that will always be in the middle. Okay, how fast is this thing going? HO is your original height. Alright, so that's if something's being thrown. 9 times out of 10, I'll give you the formula already filled out, but in case I don't, you need to know what these pieces mean so you can substitute in the correct numbers. A falling object, so this formula is used when an object is being dropped. Okay, so our keyword should change. I just never change this worksheet. So things like dropped, fell. Okay, something happened naturally. You're not throwing anything. It just kind of rolled over and fell off the desk. Okay, rolled over, fell off the mountain, kind of thing. Okay, there's no force of motion coming behind it. So again, H of t still represents height at time t. T is still time, and HO is still your original height. Okay. A little spoiler here, if something is being dropped, okay, your original height is also your maximum. Anytime something's being dropped, your original height is also your maximum. Okay. So we're going to talk about one type of problem today. On these common questions, we're going to talk about the second set of questions here. We're going to talk about how long it will take for an object to reach the ground, or when will that object hit or reach the ground. Okay. Anytime we see this phrasing, we're going to set our problem equal to 0, and we're going to solve. And when we solve, we're going to either use the quadratic formula or the square root method, just depending on what our problem gives us. So let's look at some examples out of the back. Okay. So what I want you to do when you take these notes is I want you to split your page in half, because we'll have to add some more notes to these later. So if you'll just put like a dashed line so we can talk about all these things here. Okay. Alright, so you drop, not throw a rock off of a cliff. So if we drop a rock, we're using a falling object equation. So we'll use H of t equals a negative 16t squared. And here's my original height. Okay, this is falling at 520 feet high. So what we're going to solve today, what we're going to practice is how long is it going to take to reach the ground. So to do that, I'm going to set this equal to 0. Okay. When you have two terms, okay, you want to double check what you have. So I have a t squared and I have a constant. When I have t squared and a constant, okay, I'm going to solve by square roots. Okay. To solve by square roots, I'm going to subtract that 550 to the other side. 520. I'm then going to want to divide by a negative 16. And that is going to get me t squared equals, pause, I didn't bring a calculator over here with me. I get 32.5. Okay. But in order to find the time, or how long it will take to reach the ground, I need t totally by itself. So that tells me I need to square root both sides. So t is going to equal 5.7. Now, why did I not put a plus or minus in this case? I'm talking about time. Can time be negative? No. So if time can't be negative, we'll just talk about the positive solution. Example number 3 is just like this problem, so I'd like for you to pause the video and try solving example number 3 on your own. Alright, I hope you really did pause the video, because here's the answer to number 3. Again, it was being dropped, so I solved by square roots. And it's going to take me less than half a second for me to drop my pencil. Okay, let's think about this. If you stand up and you drop your pencil from your waist, okay, it's going to take less than a second for it to hit the ground. Okay, most people's hips are almost 3 feet off the ground, depending how tall you are. Okay, so that puts it in perspective. You just hold your hand out and drop it. It's not going to take longer than a second for it to hit the floor. Let's look at example number 2, an object that's being thrown. Alright, an object that's being thrown or projected, we want to use this equation here. So you throw a ping pong ball. So h of t equals a negative 16t squared. I need to know my velocity. My velocity is always at feet per second. It's a rate. Velocity is always a rate. So plus 24t. And my height is 40. Okay. So if I want to know how long it takes for this thing to hit the ground, we have to set it equal to 0. So 0 equals a negative 16t squared plus 24t plus 40. And we're going to use the quadratic formula here. Okay. So remember, we'll start with our discriminant, b squared minus 4ac. That's 24 squared minus 4 times 1 times 40. And that should be a negative 16. I apologize. So b squared, 24 squared, minus 4 times a is a negative 16, times c is 40. So 24 squared minus 4, negative 16, times 40. And we get 3136. Remember, that's positive, so I should get 2 answers. Okay. So let's use our quadratic formula. Remember, our quadratic formula is the opposite of b plus and minus the square root of b squared minus 4ac. And this is going to be all over 2 times a negative 16. So the first thing I want you to double check is to see if 3,136 is a perfect square. And it is. Okay. So we'll squeeze it in here, a negative 24 plus 56 all over a negative 32. And then we'll have a negative 24 minus 56 all over a negative 32. So in your calculator, type in the top row first and then divide it by negative 32. So negative 24 plus 56, get an answer. Divide it by negative 32. That gives me a negative 1. A negative 24 minus 36. If I divide that by negative 32, This gives me 1.875. So if I'm trying to find how long or at what time this takes for it to hit the ground, which one's going to be my most appropriate answer? The positive one. Again, number 4 is just like number 2, so I'm going to challenge you to try this one by yourself. All right, let's check our work. Our velocity was 32, it should go in the middle. Our height's 128, that's going to be our C value. You get a positive discriminant to have 2 real solutions. If you check, that square root does in fact have a perfect square, it's 96. Okay. So when we solve that in our calculator, you should get 4. Okay, it should take 4 seconds for me to catapult myself and hit the ground. If you flip over to the next page, this is a really good keywords chart. It tells you all the keywords that you're trying to look for. Okay. So, example, this 0 gets thrown out because it's negative. Okay. How high off the ground did the object start? Okay, that question's always asking for the y-intercept. Here are the questions that go to a vertex. Okay. And here are the questions that you can ask for how long something hits the ground.